So I thought because most of these videos don't have associated problems, don't have associated videos, I thought I'd record like a playthrough, like they do with the video games. Not quite as exciting, but it'll probably help me get some work done. So I do have a video more or less that I added for problem one, so I won't go into that here. And then problem two, I also did something with this linearization. This linearization idea is a small piece. I mean, it's important in historically, and if you start using calculus in a job, you may be using it. As far as the course, it's a small piece. So just know that it's a point. So you need a slope, you need a point, and then you can write it point slope form or some variation in that. Okay, so it's not bad. I'm not going to do anything with the error, percent of error. Sometimes that we do that in courses. I know in the textbook they do. Don't worry about that. So here, let's go to problem number 3 here. So now what we're going to do is this week talks about the linearization. It talks about maximums and minimums and how we can find that out. And then the mean value theorem. And that's so what I'm going to do is, and some of these questions have more than one situation will pop up at you. So I think this one is random. So it'll still be a linear function, but there are some others that have different functions. And as I go to those, I'll try to point those out. I'll just record one version of them. And why don't I turn this video off too? Because that way, if it's just not there. Okay. But anyway, bye. Let's see. So how do I turn off the video here? There you go. All right. So what am I seeing here? I see a linear function, and the linear functions are either always increasing or always decreasing. And more importantly, the slopes are constant, right? The slope of this y equals mx plus b is m equals 5, right? So that would mean that f prime of x equals 5. The derivative is 5. So so a critical value is where, and if you've watched those other videos, a critical value is where the derivative is equal to 0, where it's undefined. Well, this is a constant. So this is always defined and it's never going to be equal to 0 unless it is 0. So in this case, what's a critical value? When is it d and e? Because there are none. When is it increasing? Well, if we think about this linear function, it has a y-intercept 2, a slope of 5, 1, 2, 3, 4, 5 over 1. That function is always increasing because the derivative is always positive. So this is always increasing, and I would try this. I tried this as an earlier version, and it didn't, my open math didn't like this. So maybe I just had them backwards. I don't know. Maybe I put decreasing on top and increasing the bottom. I don't know. But DNE, it never is decreasing, it's always increasing. And then because this is an open interval, right? They didn't tell us to find it on 0 to 10. You know, it goes to infinity in either direction. So because as x goes to positive infinity, y goes to positive infinity. As x goes to negative infinity, y goes to negative infinity. There's no minimums or maximums. It's just always increasing forever. So for this next little bit, I would say D and E. Don't put, you're going to do D and E in both of those. It's asking what is the what's the relative maximum, what's the minimum relative minimum. Those don't exist. So okay, so that's that question. And then question number 4 is a quadratic. Now let's go do big picture thinking here with this quadratic. Okay, I know a quadratic equation is a parabola. Because this is a negative leading coefficient, I know it's going to open down. So as x goes out to negative infinity, y goes to negative infinity. As x goes out to positive infinity, y goes to negative infinity. I just don't know where the vertex is. But if you remember back in pre-calculus, maybe algebra 2, if you do x equals negative b over 2 times a, that'll be the x-coordinate of the vertex. Well, let's see, 2 and 2's cancel. Negative 99 divided by negative 9 is 11. So the vertex is happening here at 11 when x equals 11. So my graph's a little off, but 11. And then what's y going to be? Well, then we're going to do -9/2 times 11. We're going to evaluate. I'm doing some evaluating f of 11 because to find the vertex. 11 squared plus 99 times 11 plus 5. And let's see, give me a minute here to find my calculator. Here it is. I won't do the on-screen one. Let's see. I'm going to do -4.5 times 11 squared, which is 121. I know I could do 11 squared, but I know that what it is. And then plus 99 times 11 plus 5. I'm getting 549.5. I did that right. -9 halves is -4.5, right? 8.5, 4.5, right? Plus 99 times 11 plus 5. Yeah, so I think I did that right. So my maximum value is here, way up here at 11,549.5. And so we were able to answer all of these questions. So let's think about answering the calculus with this now. Are there any critical values? Yeah, there's going to be one, and that happens when x equals 11. Okay, because that's where the turning point is, right? We'll show derivatives. We'll use derivatives to figure that out. When is this function increasing? It's increasing here. Let me get a pointer going. This function is increasing from -infinity until 11, then it's decreasing 11 until -infinity. And then what's the relative maximum, relative minimum? Well, this actually has an absolute. It's not asking you for absolute here because it's not on a closed interval again. So they just say in relative. Well, actually, this maximum is an absolute because that's as high as this function's ever going to get. So at x equals 11, there's that maximum of that, and there's no minimums because it goes on forever and ever, right? It's a -infinity. So we'll write D and E down here, D and E. Okay, so how do we do this with calculus? Let me erase some of this because I don't want to lose the graph. I don't want to lose that. Okay, so what's the derivative of that power function? Well, f prime of x equals -9x. Oops, -9x. I'm focusing on that too. Sorry about that. Right. -9x plus 99, right? So where does that equal to 0? I'm going to subtract 99. Then I'm going to divide by -9. And lo and behold, we get x equals 11, which what we got when we did that -b/2a trick. So there is one critical value. And if there is a critical value, we're going to write 11. And then when is this function increasing? It's increasing from -infinity until 11. And then when is it decreasing? From 11 to +infinity. Now, what if we didn't have that nice graph? Remember, we can do a little number line here, mark 11 on it. I pick a number to the left of 11, like 0. Well, that's positive, right? If I substitute in 0, isn't that 99? And what if I pick a number greater than 11, like 100? Well, -900 plus 99 is a negative number. So because the derivative is positive, it's increasing from -infinity until 11. And because the derivative is negative, the function is decreasing from 11 to +infinity. See how that works? And then how do we get the relative maximum, relative middle? It's only a maximum. I'm sorry, I already talked about that. So the critical value is 11. So we're going to drop 11 into the original function, which I did earlier, right? -9/2 times 11 squared plus 99 times 11, 99 times 11 plus 5. And you crunch that, you're going to get 549.5. Okay, and that's the maximum, and there's no minimum with D, D, and E's for those, as I said before. Okay. And we're up to question number 5. So now I'm seeing a cubic function. I know cubic functions. Well, for this cubic function, I know that as x goes to negative infinity, y heads down to negative infinity. And as x goes out to positive infinity, y heads up to positive infinity. I just don't know what's happening in the middle. And without some graphic calculator, I would have a hard time figuring that out. However, calculus does a beautiful job with this, especially this is a nice power function. What's the derivative of that? So I'm going to get 6x squared minus 24x plus 126. And then to get the critical values, I want to know, when is that equal to 0? Well, one thing I can do, I mean, certainly could use it's a quadratic, could use quadratic formula, but I also noticed that I can divide everything by 6. So 6x squared divided by 6 is x squared. Negative 24x divided by 6 is negative 4x. And then 126 divided by 6 is 21. Positive 21. Now, if I divide 0 by 6, it's out of the way. So all I got to really zoom in on is the x squared minus 4x plus 21. I could use a quadratic formula, but this also factors very easily to x minus 7 times x plus 3. Because if you subtract 7 and 3, you get 4 in the middle, and it's negative. So when x equals 7, there's a critical value. When x equals negative 3, there's a critical value. Okay. So that's what I would put in here. In fact, I would put I would do negative 3, 7 is how I would try to answer that. So now, is it where are the turning points? Are they turning like, is it turning like this? Probably, probably that's where it is, but I don't know for sure without doing a lot more work. So all I'm going to do for this question is think about the derivative. Okay, and what I'm specifically going to look at is 6 times x minus 7 times x plus 3. That factored form, it is positive, right? Yeah. So I'm going to test, and again, see, this is not a closed interval, so we don't have any endpoints. So all we got to worry about is, as far as maximums and minimums, are those two values. We're going to test this. So if I drop in, let's see, a number smaller than negative 3 is like negative 10. Well, 6 is always positive. Negative 10 minus 7 is negative as a negative number. Negative 10 plus 3 is a negative number. Negative times a negative is a positive times that original positive. The function positive there, or the derivative is positive there. Now we'll pick a number in between negative 3 and 7. 0 works well. Well, if we use 0, 6 is positive, 0 minus 7 is negative, 0 plus 3 is positive. I'm only seeing one negative, so that tells me the derivative is negative there. And then when I go bigger than 7, I don't know, 100, that'll be positive, that'll be positive, and that'll be positive. That's positive. So where is this function increasing? This function is increasing from negative infinity until negative 3. And then do they want to use commas or the u? Looks like they want to use, really on paper, I would write u 7 to infinity. Math's looking for a comma here. And then when's it decreasing? Between negative 3 and 7. That's because the derivative is negative. Okay, now we're going to find the maximums and minimums. So I only have negative 3 and 7. So let's substitute in negative 3. Let's put in 7. Here's x's. Here's f of x. So now we're going to evaluate that original function with negative 3. So 2 times 3. Actually, let's just a minute here. Let me get I'm going to do this with the calculator. Let me pull up my calculator on screen so I can show you a trick in case you don't know it. So you can certainly use y equals, type in that equation, y equals, and then use it that way. Sometimes, though, it's just as fast here. Let me clear. I know you can only see part of my entry key. But what you can do is we want to evaluate this at negative 3 and then again at positive 7. So I'm going to type in negative 3 hit equals. And then what it did is it just copied -3, no surprise there. But then what you can do, see, that's the last calculated answer. So what you can do is you can just type in 2 times second answer squared or cubed, the third. So raise it to the third power. You get a right over it. And you're saying, why is this any easier than anything else? You'll see. Give me a minute. -12 second answer squared minus 126 times the answer. Notice I'm not putting any multiplication signs between them. Plus 1. Make sure I get that typed in right. (2x cubed minus 12x squared minus 126 plus 1. Okay. So I'm going to hit enter. So that is the maximum that's happening at -3. And then here's the beauty of this. This is why this is worth doing. I'm going to put 7, hit enter. And instead of having to type all that in again, I can just do this. And that's the minimum. Okay, pretty small. Okay, so that's how we find the maximums and minimums and where they happen in the critical values, and what they are. You got to evaluate the original function. So 2 things you got to remember: to evaluate where it's increasing, decreasing, use the derivative, look for positive and negatives. How do you find the max mins? Well, then you use those critical values, and then you use the original function. Okay, so hopefully that works. And then of course, if it's a closed interval, you get the endpoints to worry about, but nothing here. Those are coming up soon. All right, and this is just the this is just the exact same kind of problem, right? And it's another cubic equation, so I won't bother doing a video for that. It's the same thing. Take the derivative, check it out. It might be a twist to it. Now these next 3 questions are, everybody gets the same version of it, so I won't go too far into depth here because I want to give you a chance to do that and won't just give you the answer. Though if you have trouble, ask in the forum and I'll give you the answer, but let you work on it. Remember, the minimums are the lowest points, the maximums the biggest points, and if it's an absolute, it's going to be higher than anything else. If it's the absolute minimum, it'll be lower than anything else. Okay, so and all they're looking for is the y values, not the x values. Okay, and it's possible for a relative min and an absolute min to be exactly the same. And notice this isn't a closed interval, so it may not be an absolute max or an absolute min, depending on your version. Okay, so same deal, same kind of thing. Same deal here. Same deal here. And now I believe, now this is into the question where everybody could get a different version of it. If I could close this out, but then I would lose my progress. I don't want to do that. You might have an exponential, you might have a logarithmic, you might have a rational function that you had to deal. Might have a radical function. So, but the process is the same. You take the derivative. Now notice this is some things that I'm noticing about this question is that's different from what we've done yet on this video, is I've got a closed interval. So I know I'm going to take the derivative. I'm going to look for critical values if there are any. And then I'm going to test those critical values in the endpoints to see which is the minimum, which is the maximum. So the derivative of, let's see, where's my pen here? Come on, oops, gonna have it upside down here. What's the derivative of e to the x? Well, that's e to the x times ln e, which is 1. What's the derivative of -1? -1x? -1. And I want to know, when does that equal to 0? So when does e to the x equal 0? Or equal 1? They brought 1 over there. Well, the only place e to a power is 1 is when x equals 0. So x equals 0 is a critical value. And that's the only critical value. So we're going to test the endpoints and that critical value. And then we're going to substitute it into the function. So it's e to the x minus x. So e to the negative 5 plus 5, right? Negative 5. And then e to the 0 is 1, minus 0 is 1. And then 2 e squared minus 2. So e squared minus 2. So now we're going to decide which is the biggest, what's the smallest. And you could surely grab a calculator, and then you got to key it in. So sometimes it's good to reason this out. E to the negative 5 means 1 over e to the 5th, which is a very small number, plus 5. So this number is actually just a little bit bigger than 5. This one is going to be 1. And then this one's going to be, let's see, e is what, 2.7-ish? And 2.7 times 2.7 is, well, let's see, 3 times 3 is 9, and 2 times 2 is 4. So it's going to be someplace between 4 and 9. So, well, you know what? I'm thinking, what if it's 9? 9 minus 2 would be 7. Well, it's going to be less than that. And if it's going to be 4 minus 2, that'd be 2. So I'm a little leery about saying that which one of these is going to be the maximum. I suspect it's going to be this first one, but I don't know that for sure. So what I'm going to do is I'm going to grab a calculator. I'm going to calculate. I don't need to worry about the e to the negative 5 plus 5, because I know that's just a little bit bigger than 5. I am concerned about e squared. I'm not quite sure what that is. I'm going to do e squared minus 2. I'm getting 5.3. Woohoo! Maybe I better do 5 plus one divided by e to the 5th. I know this is going to be smaller than the other one, but I just want to make sure. I'm getting 5.006. So this is the maximum. And what I'm going to try with my own math. Oh, they don't actually ask us the y values, do they? So it doesn't matter. As long as I know which is the biggest, so I know the absolute minimum happens here. Let me get I'm going to test myself here, see how I do. So the minimum happens at, oh, I didn't do the minimum. When x equals 0, y is 1. That's smaller than the other two. So when x equals 0, there's a minimum. The maximum happens at 2, I just said. All right, let's see how I did. Oh, I guess I didn't do too well there. So let's figure out what I did wrong. Let's see. Oh, do you see what I did? I see. Do you see what I did? I mixed up the max and min. So 2 here. Helps you read the question, huh? All right, so let's do the next question. Another question just like this. I do know this is a linear function, and so that it's always decreasing, right? And there's no critical values because the derivative is going to be -1. So all we got to do is look at the endpoints. Now, because they aren't really caring about the maximums and minimums, what they are, they just want to know where it's happening. Because this function is always decreasing, right? One, two, three. It's got a 1, 2, 3. It's got that's more or less that line. And at -1, it's up here. At +2, it's down here. We can see the maximum happens at -1. Yeah, so absolute minimum happens at 2, the endpoint, and the maximum happens at -1. And I'm sure I'm right. I'm sure I'm right. Oh, what do they want me to do? As coordinates? Oh, they do want me to find the value, don't they? Oh, okay. So -1, and so 3 minus -1 is 4, isn't it? And then, oh, the minute I get those backwards, I would do it again, huh? I almost did that again. Maximum's there. The minimum happens at 2, and 3 minus 2 is 1. So 2, 1. Let's see how I do today. There we go. All righty. I see a parabola. You could certainly do this without calculus, but this is a calculus course, so let's talk about what we're going to do. So let's take the derivative. Derivative of 5 is 0. And then we got power function, so negative 4x. And then find the absolute extrema on this function. Okay, so where does that, so here, on that interval, right? So when is h prime of x equal to 0? When is negative 4x equal to 0? Well, that happens when x equals 0. So I'm going to test negative 3. I'm going to test 0. I'm going to test 1. And here's x. Here's my f of x. So 5. So I better write this out. 5 minus 2 times 9, right? Because negative 3 squared. That's going to be negative 18. 5 minus 18 is negative 13. If x equals 0, y is 5. If x equals 1, y is 3. So the absolute minimum is happening at negative 3. The absolute maximum is happening at 5. So they want me to write them as coordinates here. Let's see how I do. Negative 3, comma, negative 13. Good. I'm not mixing up my minimums and maximums again. And here's a maximum that happens at 0, comma 5. Here we go. Same deal, just another function, right? You want a video? I'll record it. Whether or not you want to watch this part of it, that's up to you. Said I was going to do a playthrough, so we'll do the playthrough. So y prime equals, I'm going to do 3x times 2/3, and then maybe I should have written that in front. And then we're going to do negative 1/3 for the exponent minus 2, because the derivative of negative 2x is 2. And then what's 3 times 2/3? I think it's 2. And then I'm going to write it out this way. T over the cube root of x minus 2. And I want to know, when does that equal 0? So what I got to do to solve that equation? Well, there's a couple things I could do. Why don't I do it this way? I'm going to add 2 to both sides. So 2 over the cube root of x equals 2. Now I'm going to multiply both sides of this equation by the cube root of x. So 2 equals 2 cube root of x. Now I'm going to divide by 2, I get 1. And to get rid of the cube root, I'm going to cube both sides. So I get x equals 1. So there's only one critical value. It's the endpoint. So all I've got to do is test negative 1, 1 in the original function. Well, at least it's going to be easy calculating. If I square a negative, it turns positive. So right, I'm doing 3 times negative 1 to the 2/3 minus 2 times negative 1, right? If I square, remember, this is 3 times, I could write it this way, the cube root of negative 1 squared. It's perfectly okay to write it that way. Negative 1 squared is positive 1. The cube root of 1 is 1. Times 3 is 3, and then minus 2 times minus 1 is 2. So 3 plus 2 should be 5. Then we're going to test positive 1, and I think we get the exact same value. No, we don't. We're going to get 3 again, because the positive squared gives the same. But this other one, we're going to get minus 2. So that's going to be 1. So I see a minimum at 1, so I get the point 1, 1, minimum at 1, 1, maximum at negative 1, 5. Let's see how I did. No, it didn't like something. Oh. 1, 1, negative 1, 5. Let's see what I did wrong. Let's see here. Here's my derivative. Oh. You probably caught this. You probably caught my mistake. What the heck is Dan doing? And that too. That's unfortunate because it doesn't clean up so well. I should be doing these ahead of time rather than just live on the screen so you don't see these kind of mistakes. Oh, but isn't that interesting that I wrote it correctly here, but I just had the 3 wrong there. Well, let's make sure I get that right. The 3 cancels out and the 2 remains. Okay, so that's okay. And the derivative of negative 2x is negative 2. I'm gonna stare at this for a minute. Okay, for this one, and I really hope you just didn't see the stuff, my mistake I just made with all this, but anyways, so hope it didn't confuse you if you did. So I noticed it is a closed interval. We need to take the derivative. So y prime equals 2/3 times 3x to the negative 1/3 minus 2, because the derivative of negative 2x is negative 2. And then the 3's cancel out, so I'm left with 2x, the negative 1/3 minus 2. I really detest negative exponents. They confuse the crap out of me. I mean, I know how to deal with them. That's what makes it easy. So I wrote that as 1 over the cube root of x. Now I'm going to solve this. Well, first off, before I go any further, and this is the mistake I made earlier, the derivative doesn't exist at x equals 0, doesn't it? So when x equals 0, that's a critical value. Now let's see if there's any zeros. So 2 over the cube root of x has to equal 2. I'm going to multiply both sides by the cube root of x. So 2 equals 2 cube roots of x. Divide both sides by 2. I get 1 equals the cube root of x. Then I cube it. I get x equals 1. So that's the other critical value. And it happens, notice that also becomes the endpoint. So I'm going to test -1. I'm going to test 0. I'm going to test 1. F of x. Let me do some erasing here. So let's see. 3 times, remember, now I'm going back to the original function. So 3 times -1 to the 2/3, which is the cube root of -1 squared, minus 2 times -1. Cube root of -1 is -1, squared is 1, 3 plus 2 equals 5. Then I'm going to do 0. If x equals 0, the whole thing is 0, right? Because 0 to the 2/3 is 0 times 3 minus 2. And then if we substitute in 1, I believe I get 1, don't I? Because 3 times 1, it's the cube root of 1 squared minus 2 times 1. That's 3 times 1 minus 2 is 1. So I'm seeing at x equals -1, y equals 5. I'm just checking this on my calculator. I'm sure I'm right, but yeah, I'm getting 5. That is the maximum. And then it goes down to 0. Yeah. Okay, so what I'm going to do to see if I get this right, the minimum is 0, and that happens at 0. Oops, I need to write a point, don't I? Type your answers as coordinates. So 0, comma 0 is the minimum. Whoops, not period, comma 0. The maximum is happening at -1, 5. Maximum -1, 5. Now let's see. It likes the minimum. It doesn't like the maximum. But boy, that's what I'm seeing. I honestly think this problem is broken. I'm looking at the graph, and on that interval, the maximum is 5. So I either something's wrong with the way I'm typing it in, or it's just a broken problem. Okay. So hopefully that doesn't happen with it. This is one reason why I say try them all, get a 70%. I'll write in full credit because this kind of quirky thing that happens with my open math. The price is right. Okay, 15. Here we go. Find the absolute extrema of sine x on that closed interval. Okay, you see, I've already answered this question. I'm learning my mistakes. I gotta do this work ahead of time before I try posting the answer. So I'm gonna take the derivative. It'll make for a shorter video. So I gotta take the derivative. Derivative of sine x is cosine x. And where does that equal to 0? Well, it's equal to 0. Well, a couple places. Let's think about the unit circle. I know whenever it's 90 degrees, pi over 2, that those coordinates are 0, 1. And this coordinate is 0, -1. And we know that cosine is the x coordinate. Sine is the y coordinate. So the cosine is equal to 0 at pi over 2 and at 3 pi over 2. But then they throw this closed interval. 5 pi over 6 is over here. Reference angle of pi over 6. So that's going to be 1/2. That's going to be the square root of 3 over 2 and negative. And that's 1, of course. And 11 pi over 6 is over here. Just 1 pi over 6 less than 2 pi. And that's -1/2. And that's positive root 3 over 2. Because they're 36 right triangles, right? So now let's do some evaluating. I've got to do these endpoints, 5 pi over 6. I've got to do 3 pi over 2. I've got to do 11 pi over 6. And what is the sine of each of those? Well, we know the sine of pi over 6 is 1/2. 5 pi over 6 is 1/2. We know the sine of 3 pi over 2 is -1. We know the sine of 11 pi over 6 is -1/2. So notice that the maximum is happening at 5 pi over 6, and it's 1/2. And the minimum is happening at 3 pi over 2, and that's -1. Okay, that helps. All right. I'm gonna stop and do this by myself, and then I'll come back. Just I think it's easy. I think I could probably do it without that, but let's try it. Yep, I did it first try. I thought so, but it's okay. Now so I'm going to do the derivative of that function. Notice it's a closed interval, so that helps. So the derivative of that function is what is it? 14 and 0 and -2x. Right? So when that equals 0, 14 minus 2x, doesn't x equal 7? Subtract 14 divided by -2. So we'll test 4, 7, and 8. X, f of x. And I don't know if you need me to do this. Remember, going back to the original function, so it's going to be 14 times 4. I'm only doing this because I don't want you to go back to the derivative. That's a mistake people make. That's a mistake I've made sometimes. Negative 4 squared. When I do that, I came up with -18. I did the same thing for 7, came up with -9. I did the same thing for 8, came up with -10. So minimum's happening at 4, maximum's happening at 7. Okay, and see the way they're having us type it in here, which is better than that point, but I don't know, maybe it's not any better at the point. All right, let's clear this out and keep rolling. All right, another cubic function. Maybe I should do this because it's a cubic function. I don't know. gonna take a risk and do this without doing it ahead of time. Let's just see how I do. So derivative of 5 is 0. Then we're gonna get 18x minus 24 minus 3x squared. I want to know when's that equal to 0. I'm gonna I notice they're all divisible by 3, and I really hate having negative x squareds. So I'm gonna take out a -3 out of each thing and rewrite it in descending order. -6x plus 6, plus 8, right? And that's equal to 0. Again, I can divide by -3 and get rid of it. So that's going to factor to x and x. And then how about -4 and -2? Because that'll have to multiply to give me +8. So 4 is a critical value, 2 is a critical value, and we've got the endpoints. So 1, 2, 4, and 5. And then we're going to substitute those back into the original equation, right? 5 plus 9 times 1 squared minus 24 times 1 minus 1 cubed. And then you get the answer. And we'll do the same thing for each of those. In fact, I'm going to do those on a calculator. And then I'm going to come back and talk about what I got. Actually, I decided to show you on the calculator. I don't know if you've got access to a TI-80 calculator. You certainly get an emulator. I didn't, unfortunately. Did I write down the original function? Oh, no, just a minute here. I never write it down. But we've got it right there. So the way I'm gonna do this one a little bit differently. I don't know if you know how to do this. That's why I want you. This is a great feature of this calculator. So I'm going to type in that polynomial. Let's see if I can do this. 5 plus 9x squared. You probably know how to do this, but minus 24x minus 3. Remember, I'm going back to the original function, not to the derivative. I already used the derivative to find those critical values. Do I have that typed in right? 5 plus 9x squared minus 24x. 24x right there. I missed it. It's a good thing I looked. Second insert x. All right, minus 24x minus x squared, x cubed. Okay, so I'm gonna hit enter, just make sure it's there. And then I'm gonna second quit this. And then what you can do, here's the cool things about these calculators. I mean, I showed you that other way where I typed in the nth number and then used the answer. I can also do this with the calculators by typing it into the function. Then what's nice about that, I can just hit graph and make sure I'm right. I'm going to use vars, y vars 1, and then I put that function in y1. And then what you can do is you just use function notation. I want to test this at 1. I want to test this at 1. Here, let me move this over to see my red writing. Now I'm going to test that at 1. So I'm going to do y1 of 1, -11. Then I can do second. Actually, you can hit the up arrow, can't you? You can hit the up arrow and grab that again and just change the 1 to the 2. Hit the up arrow. Change the 2 to a 4. Hit the up arrow. Change the 4 to the 5. And yeah, you can use a table feature, there's all kinds of things to do. But so I see a minimum, I see 2. Wow, how about that? Oh, so I see 2 minimums and I see 2 maximums that are the same. Which is interesting. Okay, just a minute here. I'm going to write this down on a piece of paper, just so I can see what my open math is going to look for as far as putting these in. So at 1, I get -11, and then the same maximum happens at 4, and then the minimum happens at 2, -15, and 5, -15. Let's go back and see what they're looking for in my open math. Determine if multiples, oh yeah, like enter the solutions using a comma separated list. So the minimums are happening at 1, 4. Oh, no, sorry. This is the answer. This is the y, which is negative 11. And this happens at 1, 4. And the maximum, sorry, I did this wrong. The negative 11 is the minimum maximum. Negative 11, 1, 4. And then the negative 15 is the minimum, and that happens at 5, at 2 and 5, right? 2, 5. Let's see, so do I have this? So the minimum is negative 15 happens 2 and 5. The maximum is negative 11, that happens at 1 and 4. Let's see if it likes it. Oh, it did. That's always nice. Don't you like the green checks? All right. 18, getting there. Okay, I see a product rule. I see a radical. I see some chain rules going on. So let me do this offline, and then I'm going to come back with you and walk. Okay, this is the third try on this problem. I got it finally. So it's a little, it isn't that it's a hard derivative to find. It's just that it's sign mistakes is what killed me. That's usually what I do wrong. So the derivative of -1 is just a constant. So that's 0, right? And then I've got 8 times a product. So what I'm going to do is I'm just going to leave the 8 out there in front. We know that constant multiple rule about derivatives that can just come along for the ride. And then I've got a product rule going on. I've got a chain rule going on underneath the square root. I'm also going to think of that square root. So I'm going to have, I don't know what that is. I'm going to have, I've got x plus 9 times -6 minus x to the 1/2. That way I can deal with the radicals of power. So product rule leaves the first. So 8. All right, I'll write the 8. I'm undetermined to do that. I'll write it up here. X plus 9, the first times the derivative of the second. So I'm going to bring the 1/2 down in front. I'm going to leave the inside alone. I'm going to subtract 1 from the exponent. I get -1/2. And then I'm going to do the derivative of the inside, which is -1, plus the second, which is, I'm just going to write that as square root of -6 minus x, since I don't have to do anything with that, times the derivative of 1x plus 9 is just 1. Okay, so I've got that all taken care of. Now I've got to try to clean this up so I can deal with it. I know I'm going to have a fraction because I've got that x to the 1/2. And I know I've got a 1/2, so I'm going to stick a 2 in front of my square root, -6 minus x. And then I've got a -1 still on top. And I've got that x plus 9 still on top. So what I'm going to do is just multiply that -1 through and change those signs. So I'm going to write this as negative x minus 9. Yeah. And then I've got this square root of -6 minus x I got to deal with. Now I really need to have one fraction, so I got to look at my common denominator. And so that's going to be 2 times the square root of -6 minus x. So I'm going to multiply by 2 times the square root of -6 minus x over 2 times the square root of -6 minus x. That way everything's over that 2. And that 2 times the square root of -6 minus x. And then I've got the -x plus minus 9. And then I've got 2 times, now the square root of that mess times the square root of that mess cancels out the square roots. So -6 minus x. And I've still got that 8 coming along for the ride. I don't want to lose that. So then I'm going to have in the inside, I'm going to collect some like terms. I've got 8 times, and that's 8 over 1, so I'm just going to stick with the numerator. Negative x minus 9 minus 12 minus 2x, right? All over that common denominator, 2 square roots of negative 6 minus x. And now combine like terms, I'm going to get 8 times negative 3x minus 21 all over 2 square roots of negative 6 minus x. You see, before I do too much here, I can just cancel out that 2 and that 8, make it 4. That's going to leave me 4 times negative 3x minus 21 all over the square root of negative 6 minus x. Now, where is this derivative undefined? Well, if x is if x is negative 5, I'm going to get a negative number. So x has to be less than, it can't be equal to negative 6. It's got to be less than negative 6. Right? If it's equal to negative 6, then it's division by 0, and that's undefined. So that's, I guess that's what I'm looking for. I'm looking for the critical value. X equals negative 6 is a critical value. Notice that's one of the endpoints, because that's the domain limitation of this function, by the way. And then the numerator, where is that equal to 0? Well, I could distribute the 4 through, but I could also just divide 0 by 4, and that way I'd get rid of it. And then negative 3x minus 21 would give me negative 3x equals 21, so x equals negative 7. So I've got negative 7 is a critical value. I've got negative 6 is a critical value, which is also an endpoint. And then I've got the other endpoint to deal with. So I'm doing an eraser here. Let's get rid of that. Well, I've got a test. Negative 10 is an endpoint, right? Yeah, negative 10 is an endpoint. I've got to test my negative 7, and I'm going to test negative 6 in f of x, in that original function. Now, I did the same thing with my calculator, so I don't think you need to watch me do that. But what I got was negative 7. Whoops, that's weird. That's weird there. Weird. I have rough enough writing as it is without adding stray marks. So negative 17, and this one is 15, and then this is negative 1. Now, I'm going to reiterate here. I plugged each of those x values into h of x, not the derivative. And that's what I came up with, and as you can see, those were the right answers. All right, so hopefully that helps. Okay, 19. What are there? 30 questions? All right, so I've got a ln function, and okay. Let me do my thing. I'll come back and show you how I did it. Okay, so for this one, let's see here. Where's my board? I'm getting, let's see, because I see a quotient. I don't see any other way to do this except by using the quotient rule. So I'm do the bottom. I've got this negative kicking along out here. I'm just gonna leave that out there for now. The bottom times the derivative of the top. Well, the 6 is there. Actually, if I wanted to, I could pull the 6 out. I'm going to just bring it along. Why don't I pull the 6 out also? Because that is just in the numerator. So that way you can just square with the bottom times the derivative of the top, which is 1 over x plus 2 minus the top. Remember, pull that 6 out times the derivative of the bottom, which is 1, all over the bottom squared. Okay, and now then the derivative of negative 4 is 0, so we don't even have to worry about that. So x plus 2 divided by x plus 2 is 1. And I mean, I could, if I could just distribute that negative 6 back here just to clean it up a little bit. So negative 6 plus 6 natural log of x plus 2 all over x plus 2 squared. When is this undefined? This is undefined at x equals negative 2. And it's also, where is it equal to 0? Well, I'm going to bring the 6 over, divide by 6. That leaves me the natural log of x plus 2 equals 1. So then solving that log equation is a pain, so I'm going to rewrite it as exponential. So e to the first equals x plus 2. I'll subtract 2. So e minus 2 is a critical value. X equals -2 is a critical value. And we got our endpoints, -1 and 3. Oh, so look at that. -1. We don't even have to worry about that x equals -2, do we? So we're going to test -1, e to the -2, e minus 2, and then we're going to test, what am I going to test? Oh, the other endpoint, which is 3. Okay. So I did originally do this with a calculator, and it took the -4 and -1, no problem. It didn't like my answer at the other. So let's do some plugging in here. X, here's f of x. So let's see here. Let me clean up my derivative a little bit. You can always come back and watch this, and this will give me some screen real estate. I tried to do it with a calculator, and it didn't see. I didn't get full credit here because it didn't like that. It didn't like that value. So I'm going to drop in -1 to that function. So -6 times the natural log of -1 plus 2 is 1, all over -2 is -2, no, -1. So -1 plus 2 is +1. -4. Well, what's the natural log of 1? You're going to get 0. -6 times 0 is 0. 0 divided by 1 is 0. -4 is -4. Okay. Now I'm going to drop in the e minus 2. So here's how you get this. And sometimes my open math does this deliberately. They just want to make sure you can write the math and do the math without worrying about a calculator. So I'm going to drop in e minus 2. Remember, that was one of my critical values. So -6 times the natural log of e minus 2 plus 2 all over e minus 2 plus 2 minus 4. E minus 2 plus 2 is 0. The natural log of e is 1. So that's going to give me -6 all over -2 plus 2 cancels out as e minus 4. And that's what I left it, and that's what it liked. And then, of course, for 3, it's some messy number. Let's see. 6 times the natural log of 5. Oh, it's -6 times the natural log of 5 over 5 minus 4. Some miserable number. I think if I grabbed a calculator for it. Did I do it on the screen? Did I get it? Let me see if I've got it on my screen calculator. So I think I was prepping for to show it with you. Yeah, the -5.93. So that's not as small as the -6.2-ish number. So I knew I had a minimum at e minus 2, and I just, but my math wanted me to have that expression rather than the decimal. Okay, so hopefully that helps. Let's see, we're going to problem number 20. Okay. So what's the derivative? You know what? I'm gonna pause this. Okay, this question, same kind of deal. It's on a closed interval. One thing I want you to pay attention to, though, is notice that tangent's only defined from -π/2 to +π/2. There's a vertical asymptote at each of those endpoints. So even though it's a closed interval, we're not going to be able to evaluate this function at those values. Okay, so, but the same process, we're going to take the derivative. Now, this required a lot of writing. So what I did is I did this on paper and uploaded it, and I'll talk you through what I did. Okay. So here's the function here. I hope you can see that all right. Can I maximize this? Let's see. Yeah, so there's the function. I took the derivative, and then secant squares are always cosecants are always a pain, so I rewrote it as a cosine. I set it here. Let me get a pointer here so I can know what I'm doing. What I'm talking about. All right, so I rewrote the secant squared as 1 over cosine squared, right? And so then I solved that for the 1 over cosine squared. So I subtracted 20 divided by 10. I got 2. I took the square root to unlock that fraction. So that gave me plus or minus the square root of 2. And then I rewrote it. Secant's the reciprocal of the cosine. So since this is the reciprocal, I took the reciprocal of the other side and came up with that and rewrote it as that. And then I know I'm on, so where is it cosine equal to 2 over 2? Well, I know it's 45-degree angle, pi over 4 angles, right? So, and it happens negative, it's negative down here. No, I'm sorry, it's positive, cosine's x. So in both of these situations, it's positive. So we can ignore the negative square root, right? Because on this interval, cosine's positive, and 1 and 4, right? So I know my critical values. I know it's pi over 4, 45. So I know those are my 2 critical values. And then it's asking me about increasing and decreasing. So I automatically jump to that number line. I wrote in my endpoints. I wrote in my critical values. So then I tested, and I ignore this stuff. That was scribbling. I substituted in -1. I mean, I want a nice number to have to deal with, so I used -1. And then what I did is I pulled out from my calculator, and let's see, where did I do this? Yeah, so here's the secant. So -1, you lost it. You can't see it. Well, here I can do it here. See how? Well, let me do it. For cosine of 0, it was positive. For cosine of 1, when x equals 1, it was negative. When I plugged in -1, it was the exact same value, negative. So that's why I went back here. I wrote negative in here, positive in here, negative in here. So this function is increasing from negative pi over 2 to negative pi over 4, and or from positive pi over 4 to positive pi over 2. And then it's decreasing between negative pi over 4 and positive pi over 4. Okay, so I know that's where I mean it's decrease and decrease, when increase and decrease. And then they want about the maximum minimums. So I wrote down my critical endpoints. I wrote down the critical values. Of course, the endpoints don't exist. So I substituted in negative pi over 4 in for the original function. And I know the tangent of negative pi over 4 is -1, because the tangent of 45 degrees is 1, and it's down in quadrant 4, so it's negative. And you can evaluate that in a calculator and you get it. So -10 times -1 is going to be +10, and then 20 times negative pi over 4, the 4 and the 20 cancel out to 5, so -5 pi. And then I did the same thing for positive pi over 4. We get the same values, except the 10 is negative, and the 5 pi is positive. Well, this is 15, better than 15 minus 10, and this is going to be 10 minus something that's better than 15, so it's going to be a negative number. So this is the minimum, this is the maximum, and this is where they occur. So then when I went back to my open math, let's see, it's decreasing here. Where's my paper here? So it's decreasing on negative pi divided by 2, comma, negative pi divided by 4. And I'll do a parenthesis, then I'll do an interval u, just in case it's not liking it. Sometimes my math doesn't like that. Then pi divided by 4, who knows? It might not even like what I'm putting in now. 2 pi over 2. Whoops, except it's something like that. Divided by pi over 2. Well, what the heck? Comma. Pi divided by 2. Is that what it was? I was just missing a comma. Yeah, all right. Online math. So that's when it's decreasing, because those are the 2 places it's negative. Then it's increasing on the interval negative pi over 4 comma pi over 2. I almost said 4. And then it has a local minimum. Where did I say the local minimum was? At negative, no, at negative pi over 4, right? Isn't that what I said? Let's see if I can find my work again, just so I make sure I'm looking at the right thing here. Yeah, the minimums happen at negative pi over 4. That's what we found. And that's what I found. So they want a point. See the way they write that? So they want a point. So negative pi divided by 4, comma, and then I don't know if it'll take a decimal. I think it's looking for an exact value. So that's why I had to do that. 10 minus, and then it has a local maximum at positive pi over 4. Oops, didn't like that. Positive pi divided by, let's get a caps lock on it. What's happening? Pi divided by 4. Whoops, and now I don't have my parentheses. You can say, what the heck, Dan? Pi divided by 4. I'm getting punchy. I'm doing this all in one day, and it's a lot. That's why I don't want you folks to do it all in one day. And I know what I'm doing more or less. What is it? 10 plus 5 pi? Oh, it's negative 10 plus 5 pi. Negative 10 plus 5 pi. I'll be interested. I haven't tested this to see. It just made sense. We'll see what happens. What doesn't it like? Okay, it just doesn't like this. Oh, Dan LeMay. It didn't like my U? Oh no. It's decreasing. Oh, it's negative pi over 4. Negative 4. That's what it didn't like. You're probably saying, Dan, you missed that. And I did. All righty. So this is number 20. Woo, 21. Okay, so we got to do some. I see a log function. I see a square root function. Do I want to risk this and do this on live? Let's try it. I don't think it's that bad. Where's my pen? Here it is. So the derivative of ln x, 14 ln x is 14 and over x. And then this is negative 13x to the 1/2, right? So minus 13 over 2x to the negative 1/2, and the derivative of 10 is 0. So I want to clean this up a little bit. So 14 over x minus 13 over 2 square roots of x. Okay, so what's my common denominator? Because that's what I really want to do. Do you see this is just the square root of x times the square root of x? So what's happening is this square root, this fraction is missing the 2, but this is missing the square root of x. So I'm going to multiply this by 2, and I'm going to multiply this one by the square root of x over the square root of x. So that gives me 28 minus 13 square roots of x all over 2x. I believe I did that right. We'll find out. I don't like this 13. This is going to be kind of messy, but maybe we're okay. So where does, so I know this thing's not defined when x equals 0, and that's not in the domain, the closed interval that we're looking at. So that's okay. Let's see what happens with a 28 minus, and it'd be really wonderful that was 14 rather than 13, but oh well. Where is that equal to 0? Just a minute, folks. Before I go much further, let me do this rather than making a long video of it being wrong. Okay, so I was on the right track. I didn't go astray, and my math liked what I got. So I combine those two fractions here. Let me get a pointer going again. I combined those two fractions, got that. I knew x wasn't equal to 0. I probably already said this, but I know 0 is not in the domain of that range, so it was okay. Domain of what they told me, the closed interval. So where's this equal to 0? Well, I set the numerator equal to 0. I moved the 20. I moved. What did I do? I guess I moved the 13x 13 root x over to make a positive, and I divided by 13, and then I squared both, and I said that's an awful number. Let's make it a decimal. So I made it a decimal, and then they were just asking me for max and mins. They weren't asking me about increase and decrease, and so I started to do the increase and decrease, and I just left it alone. So then I substitute in 2 and that rounded number for the critical value, and then the other endpoint. And I just grabbed my calculator and did it, and that's what I got. So minimum's happening at 2, the maximum's happening at that 4.639 number, and make sure you're in radian mode. And lo and behold, my upper math actually liked those answers. I was shocked, to be honest with you. Okay, so there's that. I hope I just was recording, but I was. 22. Okay, let me pause this one and do this one. I'm getting punchy, that's why I got to do it. Okay, so now we're into mean value theorem problems. I'm glad. So the mean value theorem says that we have to find the place. So remember what we're doing here is we've got some curve. I don't know what the curve looks like, but the mean value says, hey, if the function is continuous on a closed interval and differentiable on that open interval, there's going to be some place on that curve where the tangent line has the same slope as the secant line, or the parallel to the secant line. And that's all it is. And we're going to solve it. So the formula is, and I hope you've read or read in the book or read something about it. So the formula is f of b minus f of a over b minus a. That average rate of change equals f prime of c, and with some number. We want to find the value of c that's where the derivative is the same as the secant line. And as you've seen, this deals with the radar detectors and all that kind of thing. So we've got the derivative. That's nice of them. So here's the derivative, 1 over the square root of x plus 11. And we want to find out that average rate of change. And so very nicely that they told us that notice this would be the A, this would be the B, right? A, B. So f of -1 is -1 minus f of -10 is -7 all over -1 minus -10, positive, positive. That gives me 6 over 9, which simplifies to 2 over 3. That equals 1 over the square root. I guess I should have a c rather than x, but it doesn't really matter. It's a variable. So I'm going to do my cross products. Actually, I'm going to cross multiply and divide, actually. So I'm going to come down to c plus square root of c plus 11 has to equal 3 over 2. And then I'm going to square both sides. So c plus 11 equals 9 over 4. And then I'm going to subtract 11, which is the same thing as subtracting 44 over 4. 44 over 4 minus 9 over 4 is 35 over 4. And of course, it's negative, and lo and behold, there's the answer. Okay. Let's go to the next one. Maybe that's as easy and I can just roll with it. On toll road. Okay, this is not evidence. All right, so this is that one. Well, let's see. So let's find the average rate of change. Okay, so he's going to pay the toll. Let's see. Let me pause this here, guys. I guess I got to read the question. So in 6 minutes, this driver went 11 kilometers. Now we want to convert this to kilometers per hour because that's what the speed limit is, right? So we know that there are 60 minutes in 1 hour. We just do a little dimensional analysis here. We see that's kilometers per hour. So I don't even need a calculator for this, do we? That's 10, 110, 11 times 110 is 11 times 10 is 110 kilometers per hour. So, oh yeah, because of the mean value theorem, I was speeding. some point. Of course, there's a video there, I just noticed. So do these all have videos? Do I not have to do these? Oh, okay, I guess I won't do any more because these all, at least these have videos. Video. Does this have a video? This one does not have a video. Let me do this one then. So it's the same thing. Here they didn't tell me the derivative, so I got to find the derivative. F prime of x equals negative 6x squared plus 18x minus 0. Okay. So that's the derivative. So negative 6c squared plus 18c has to equal, let's see. So what's f of negative 5? So that's going to be negative 2 times negative 125 plus 9 times 25 minus 1. So what's that? That's positive 250 plus, was that 225? Minus 1. So that's 475, but we take one, so 474. Hopefully I did that arithmetic right. So 474 minus f of negative 9. So if you don't mind, I'm going to pause this and grab a calculator, and I'll be back. Okay, I did do that arithmetic right. I checked myself. So when I plug that into my calculator, I got, for the second one, f of negative 9, I got 2186. So minus 2186 divided by negative 5 minus negative 9. So we're going to subtract those two numbers and divide them by 4. 474 minus the 2186, I'm getting negative 1712, and I'm going to divide that by the 4. You don't need to see that. So I'm getting negative 428. I'm getting negative 6c squared plus 18c equals negative 428. Here, let's clean up a little space here. And then I got a quadratic equation. You know what I'm going to do? Since I can, I'm going to do this. Let's see if I've got the average rate of change right. I guess I'm going to write negative 428. Let's see if it likes that. That's right. Okay, that's right. Good. Now I mean, I could just lost a little bit of the point. So now I'm going to solve this quadratic equation, which is the derivative, negative 6c squared plus 18c. And because it's a quadratic equation, we have to set it equal to 0. And then either use quadratic formula, try to factor. I'm pretty sure, let's see, 10. No, I don't know if this isn't divisible by, let's see, that's 10 plus 4 is 14. That's not divisible by 6. So I'm gonna use the quadratic formula. Actually, I'm gonna cheat. I know I gotta use the quadratic formula. I've got a solver on my computer calculator. You are more than welcome to use solvers for this in algebra 2 or calculus. Algebra 2, right? In algebra 2 would make you do it, but quad 83. In pre-calc, I don't make people do it. I mean, yeah, set it equal to 0 and then use some solver for it. Why? I mean, I got negative 7.078 and 10.078. And because we were on that interval, we want to use the negative value. Let's see if that works. Negative 7.078. Is that, that's what my calculator is telling me. We'll see if it likes it. Like, excellent. I love it when I get those green checks. All righty. Okay, in order for the mean value theorem to work, it has to be continuous in the open interval, closed interval, and differentiable on the on the closed interval. So where would not apply? So I know that this is an absolute value function. I know that the vertex is at 4, -9. I hope you remember that from algebra 2 or college algebra. So 4, -9 is where the vertex is, and that's where the corner happens. So we don't want to include that corner. So let's see, what x equals 4. So if it wouldn't apply, this is going to be fair. I don't know. I haven't done this problem. Let's see how they want it. So they want closed form. Well, let's see. Any interval that includes 4 will be wrong. So let's do 6. Okay, and when would it apply? Any interval that doesn't include 4. So how about 6? Oh, I want to go look at the code and how they program this. 10. That should work, right? That doesn't include. Yes, it's cool, very cool. What do they say? Answers will vary, right, right. So you just didn't want to include that problem. And okay, and there's a video, so I don't have to do that one. Okay, so hopefully this helps. Hopefully I didn't confuse you. Give me a yell if you need some help.